All right, everybody. So this is the week four, lecture one. And what we're going to do is we are going to go over the modulo operator, which is in this set of lecture slides. Now, this set of lecture slides here, which is called Lecture 3 Variables Part 2, we actually went over before, but when we hit the part that said modulo operator, we stopped. Also, we have the normal assignments down here, week four reading and homework and lab three. And in the lecture two that we're going to be doing, we are going to be going over a lot of the work that's in the week four reading and homework, hopefully including some of the modulo stuff. So let's go ahead and get started by downloading this set of lecture slides. I mean, I've downloaded it before, but we'll download it again. We should open that up. And we will skip to the stuff near the end where we're going to be talking about division and the modulo operator. Okay, so let's do that. So we'll skip to the end here. I'll keep scrolling. And we'll talk about the modulo operator. So this is something that you probably haven't heard of before, unlike the other stuff that's in this section, right? Because if we scroll up, we're talking about like even in this math functions, we're talking about the power function and a square root function. You've seen those before if you've taken like an algebra 2 or if you've taken a pre-calculus class or something like that. Scientific notation, you know about that. Obviously, you know how I'm scrolling up to find it. I don't see it. But obviously, you understand how multiplication and division work, right? And you understand how addition and subtraction work. So the modulo operator is something that you haven't really seen before. So here, we're in the right place now. So what is it? So the modulo operator calculates the remainder after division. And so you can think of that as long division. I don't have a good picture up here, but let's say long division. Um, let's just say long division. And we'll find a picture of long division, and that'll be good enough. Um, so here's an example of long division, right? So if you were trying to um, divide 75 by 4, the way you would do this is you would say, how many times does 4 go into 7? The answer would be one time, right? So you put a 1 up here, then you do 1 times 4, and you get 4. You put a minus here and subtract. So 7 minus 4 is 3. You bring down the 5. Then you have to say, how many times does 4 go into 35? And the answer is 8. So you put an 8 up here. 8 times 4 is 32. You add another minus sign. You subtract 35 minus 32, and you get 3, right? And and that's where you're done with integer division because a 4 does not go into 3 anymore. And we can't bring down any more numbers to the right because if we're dealing with integers, there's nothing to the right of the decimal point, and the decimal point is right here on the 75, right? So we can't bring down a 0 because that would be on the other side of the decimal point. So we're just done. Okay. So because of that, so let's try to remember these numbers. So the way you could say this is going to a place where I could type. The way you could say this is if you tried to do 75 divided by 4, for example, what we get is the answer is you get 18. That's going to be the number on the top, but then there's going to be a remainder of 3. So you could say that when you do 75 divided by 4, you get 18 with a remainder of 3. Does that make sense? And you could do this for, any kind of numbers that you want, right? Like if you say, what if you divide 12 divided by 4, for example. You get 3 because 4 goes into 12 three times with a remainder of 0, right? No remainder in that case. If you were to divide, let's say, 15 divided by 4, you would say, how many times does 4 go into 15? The answer would be 3, right? 4 times 3 is 12. You get 3, but there's a remainder now, right? Because 4 times 3 is 12, but there's still 3 left over, right? 13, 14, 15 with remainder 3. So you need to understand this concept of division with a remainder to understand what you're getting when you are looking at the modulo operator in Java. So skipping back over to where is it? No, I don't know what the preview app looks like now. They just updated Mac OS and I don't I don't know where it went. Oh, there it is. So the modulo operator, which we're going to write with the percent symbol, calculates that remainder. Okay, so it's going to be related to the division operation, but it's not division, it's the remainder. So specifically, um, actually, I don't like the way that's written. So we'll go over here. So in Java, if we do this, and we'll switch over to Java to actually write a program momentarily. But if I do this operation in Java, we'll do 75. 75 divided by 4. Okay. Then what you're going to get is going to be you get 18. I wrote that like it's a comment. But if you do 75 divided by 4, you're going to get 18 because that's how many times 4 goes into 75. If you do 75 and put a percent 4, that's going to give you the remainder. Okay. And so that 18 there is what we call the quotient. And the 3 there is the remainder, as we said. Okay. And you can do that for any of these, right? If I do 15 divided by 4 in Java, I'm going to get 3. And that is the quotient. But if I do 15 modulo 4, or just mod 4, as people will say, then you're going to get the remainder, which is in this case also 3. Okay. And so that's what it is. And so whenever you need to get the remainder, you would use this modulo operator. And you might not even care because you're thinking like, why do we want to get the why do we care about getting the remainder after the division? But you can do useful things with it. And so one of the useful things you can do with it is you can use it to convert like seconds to like minutes, for example. Convert, let's see, seconds to minutes plus seconds. Um, why S and C are right next to X and C are right next to each other. How do we do this? So as an example, let's say we had some number of seconds. Let's say we have, um, I don't know, let's just say 277 seconds. Okay. Now you know that there's 60 seconds in a minute, obviously, right? So I'm going to write recall there, but I mean, we all know. I just want to see the number. Um, there is R, 60 seconds in 1 minute, right? So we know that. Um, so if you wanted to know how many minutes this is, you would use division. So you can calculate how many minutes 277 seconds is with division. So if you grabbed a calculator, which I'll do, you could go what is 277 divided by 60? And you get 4.61 something, right? So in math, you would get 4.616666, right? Um, 277 divided by 60 equals, what did we say? 4.61? No, 4.61, is that? Yeah, 61666667. Um, that's in math though, right? Um, that doesn't help us calculate how many minutes there are and how many leftover seconds there are. But what if you want your answer like this? So this would be in minutes, right? So 270 seconds, 277 seconds is 4.616666 minutes. Okay. But what if you want it like this? What if you want your answer in, like XX minutes and YY seconds, right? Like a number of minutes and a number of leftover seconds. That's where the modulo operator would do this really easily. The modulo operator can do this easily. And it really is pretty easily. So now is where we'll open up Eclipse just to make sure we can do something. So I've got Eclipse here. Let's close this, do a new Java project. I'm going to call it mod example. Remember to uncheck this box. Do finish. Open that up, go down to SRC. We do a new class, call it whatever we want. I'll call it mod example. Check the box for public static void main. Okay, so I've got a blank project here. And what can I do with it? Well, let's just do this. Let's just say int seconds, and let's put in our 277. Okay. Now, it turns out that to get that number of minutes, right? To get this number of minutes, 4 minutes, we need to divide by 60, right? So you would say get minutes with division. So you could do like int minutes equals, and you would just take the 277, but it's in the variable seconds, so I'll just do seconds divided by 277. No, sorry, by 60. Right. Now I'm going to print it out down here. So I'll say print out results, and I will say system dot out dot print line, and I'll say minutes colon space, and then I will print out the minutes variable. So this is not like too interesting of a program yet. We would have already known how to do this, right? So we get 4 minutes. So when you use division, you're going to do 277 divided by 60. This is integer division, which means we're not going to see the 616666, etc. Because when you do integer division in Java, it chops off everything after the decimal point. So that's what happened here. So when we divided 277 by 60, it's supposed to be 4 point something, but we just see 4. But what if we want to know how many seconds are left over? Well, now you get the leftover seconds, uh, right, which you could think of, right? It's the remainder, the remaining seconds, with uh, the modulo operator. So you could say the seconds is going to be, I know that it's the same variable, but we're going to take the seconds. It's going to be just like this, seconds divided by 60. But instead of divided, it's going to be modulo 60. And then we can print that out and have seconds, seconds. And we get 4 minutes and 37 seconds left over. And a lot of times, like if you are working with time, that's what you would want, right? Like 270 seconds, 277 seconds is 4 minutes and 37 seconds. Like that's it. Now, do you ever see the 0.61 this way? No, but that's not what we wanted. We wanted minutes and seconds, not minutes and like a decimal. So isn't that neat? I think that's neat. That allows us to convert time pretty easily. Now we can modify this example to do hours and minutes and seconds. So like just to show you what that would look like, let me go down here. We'll put another one here for hours. And we'll put hours here. Now, what we'll have to do to make this work, of course, is we'll have to redo these calculations. So let's just do this. Let's say int seconds. Well, we already have seconds. Int hours, but there's nothing there. Int minutes, and we're not putting anything there, but we're going to do seconds. And let's just pick a big number of seconds. Let's make sure it's more than a couple hours. So I think that an hour is 3,600 seconds. Um, so we'll just say like, what is 8945 seconds in hours, right? That's what we're going to try to do. Convert 8945 seconds to hours, minutes, seconds. Okay, that's what we're going to try to do. Um, Now, what would it look like? Well, the first thing you have to do is you have to understand that there is, um, so there are 3,600 seconds in an hour. Of course, we know that. And we know there are 60 seconds in a minute, and we'll need both of those. Okay. So what you can do is to get your hours, right? So first we'll find hours, and you would do that with division. So you would take your hours would be, you take the number of seconds and you would divide it by that 3,600. Okay. But after you find the hours, you need to find how many seconds are left over. So then you have to find the leftover seconds. And that would be seconds equals seconds modulo 3,600. Okay, so it's like this two-step process. You can find the hours. This will be like, I guess this will be 2 hours, right? Because 3,600 and 3,600 will be like 7,200. And so this is more than 2 hours. So when you do this line, hours equals seconds divided by 3,600, you're going to get 2. But 2 hours is only 7,200 seconds. So there's a bunch of seconds left over. And this is going to calculate how many left over. After you do that, you find the number of minutes. We already did this, so we know how it looks. It's minutes equals, you have to take the seconds and divide by 60 this time. And this seconds is going to be the updated seconds, right? Like it was 8945, but when you run this to get the leftover seconds, it's going to be like, 1,500 or 1,800 or something like that. So then you find the minutes by dividing by 60. After you get the minutes, you're going to need to find the leftover minutes. Sorry, the leftover seconds again, which I can do seconds equals seconds modulo 60, right? So you can always find this leftover amount using the remainder, right? That's what the remainder means. And so if you use 3,600 in seconds, you'll be finding hours and the leftover seconds. And if you do it with 60, you'll be finding minutes and the leftover seconds. So let's find out 8945, how many hours, minutes, and seconds that is. 2 hours, 29 minutes, 5 seconds. Just like that. Um, and you can change it to different numbers. So, I can just say like, put big numbers in there, see what happens. 126 hours, 47 minutes, 45 seconds. What if you wanted to change this now and change it to days? What if we want days there as well, right? If I put a big enough number in there, like I did, then we should be able to find days, hours, minutes, seconds. So what would you have to do? Well, you'd have to put days up here, and I guess I just deleted it, so let me undelete it. So we would also have to know there are question mark seconds in a day. So we would need to know how many seconds there are in a day in order to find this. So if I put days up here, then we would have to calculate that somehow. It's not that hard, right? Like if I grab a calculator again, if you wanted to know how many seconds there are in a day, what you would do is you would say there are 60 seconds in a minute times 60 seconds in an hour times 24 hours in a day. And you would get 86,400. So 86,400, that's how many seconds there are in a day. And then in order to find that first, it's going to be exactly the same as what we did for the others. So to find the days, it would be days equals, and you would take the seconds and you would just divide by how many seconds there are in a day. So 86,400. After you do that, you need to find the leftover seconds, which is seconds equals seconds modulo 80, 86,400. Right? So do you see how we're doing the same thing over and over with like these pairs? So you find the days and then you find how many seconds left over. You find the hours, how many seconds left over. Find the minutes, how many seconds left over. And at that point, that's as far as we're going, right? Um, because we just want minutes and then seconds. So like this example we did here had 126 hours, 47 minutes, 45 seconds. But if we do it with days, then uh, it'll look a little different. 5 days, 6 hours, 47 minutes, 5 seconds. So the 47 minutes and 45 seconds, I think, is the same. But of course, now we had to take that 120 something hours and convert it to days and hours. So that's what's different here, the days and hours. And again, you can just put in numbers here. And if you put a small number in, you're just going to get 0 days, 0 hours, 7 minutes, 36 seconds. If you put in a really big number, you're going to get 52 days, 15 hours, 2 minutes, 6 seconds. Um, so that's one good application of the modulo operator, which again is the remainder. Um, what else can we do with it? Well, another thing we can do with it is there's a trick to get, you can get any digit you want from a number. That's another thing you can do with the modulo operator. I'll skip back to the web browser here, wherever it is. And no, we wanted the preview app, which is, I forgot what it looked like. This. Um, so the trick there is using the modulo with a 10. Because if you think about it, if you divide a number by 10, let's see, long division with 10. So let's see, 10. I guess it's just a calculator. So if I put a number in here like that, 5732, and we hopefully see it, um, then you'll see that when you do like 5732 divided by 10, of course, 10 is going to go into 5730. So that last digit there, that 2, is definitely going to be the remainder. Does that make sense? Because 10 only goes into things with the 0 on the end. So whatever the number at the end, that's the leftover number. Hopefully that makes sense. So what that looks like, where is Eclipse? So what that looks like is if we have like int, just do x, I guess. No, let's do num. If I put a number here like this, if I do just like int digit equals, and I just do the number modulo 10, and let's print it. Digit, digit. Um, well, we'll get rid of these, I guess. We'll just comment them out. They're still there, but we just won't print them on the screen. And let's just look at the digit that will get printed. So we get 4, right? Because that's the last digit. And I think that makes sense. Um, but the other thing you can do here is remember what division does. Remember that division, what division by 10 is going to do is like when you divide this like 5732 by 10, yes, you get the remainder of 2, but where are the other digits? Well, 10 goes into 5732 573 times, right? So if you think about it, when you do division by 10, all the digits except the last one is going to be the remainder, right? So the last digit is the remainder, 2, but the other 3 digits, the 5, 7, and 3, that is the quotient actually, right? 5732 divided by 10 is 573. And what that lets you do is chop off digits, right? So like if I want to, if instead of getting the last digit, if I wanted to chop off the last digit, I would just divide by 10, right? So when I divide this by 10 now, it's not going to say 4, it's going to say 87563. Just I'll show you, right? 87563. And so basically what I'm saying is this. So basically division will chop off uh, the last digit. We know that. And the modulo operator, I'll say division by 10, will chop off the last digit. And modulo by 10 will give you the last digit. And you can combine those two things. So like I have this number here, 875634. And if I do modulo 10, we get the 4, the last digit. What if I want the second to last digit? I want the 3. Well, you can think of that as two steps. So I'll call this digit one and we'll print it. What if I want the hundreds digit, or sorry, the tens digit? What could I do? Well, if I want the tens digit, that's the three, I would I need to chop off the four. How do you chop off the four? Well, you take the number and divide by 10. That would chop off the four. After I chop off the four, then I could do modulo 10. So this is two steps happening here. Step one chops off the four. Step two returns what the last digit of what's left, which would be the three. So if I were to print this, so this will be ones digit. This will be tens digit. I should call it digit 10, and this needs to be called digit 1. So now the ones digit is the 4, and the tens digit is the 3. And you could do this thing similarly to find any digit you want. So like if I want to get the hundreds digit, how would I get the hundreds digit? Well, the exact same process. To get the hundreds digit, you need to chop off the last two digits. You would do that by dividing by 100 and then divide by 10. So if you want to chop off two digits, you divide by 100. It's still modulo 10 because we want to return one digit. I'll change these to say 100. Right? So that's the 6. Well, what if you want the 5? The 5 would be the thousands digit, right? The thousands digit. So how would you get the thousands digit? Well, you would give the variable name digit thousand. You would divide by 1,000 and then modulo 10. And so we can get the 5, right? Five's in the thousands digit. So this kind of trick here to get like the thousands digit, divide by 1,000 and then modulo 10. So modulo 10 will always give you one digit. Okay. You can use these tricks to do other things as well. So like let's say you have a phone number. Now this doesn't work very well in Java for a reason I'll try to explain. But let's see, get the area code from this phone number. So int, and I'm going to say PN for phone number, and I'm going to say 209. I think, okay, I don't want to make up a phone number for Merced here. So if I do mccd.edu, we scroll down, we'll see the phone number for the school, I think, somewhere. Yeah, 384-6000, right? So 384-6000. Now, the reason I said that this is not really a good way to do a phone number is because if you think about it, this is three digits there, three digits there. So this is oh, oops, four digits there. Like this, if you actually looked at this number as a number, it's like 2 billion, right? 2 billion something. And also the biggest that integers can get is about 2 billion. It's a little bit bigger than this. So this works for an area code 209, but we couldn't put like a Fresno area code or something there. I think is that 559? You couldn't put that there because that number is actually too big to put into an integer. So I'm just, if you wanted to do bigger numbers, you'd have to use like a long. Remember how we learned that that exists. Um, Not an integer, but we'll just do this. Now, these underscores are not doing anything. They are just helping me visually separate the number. So let's take them away. And like, let's say I wanted to uh, get the, let's see, the 209, right? The area code there. I have to, should be in a comment. Otherwise, this will crash. Get the 209. area code from the variable PN. How could we do that? Get the area code. Well, we know how to chop digits off, right? So basically, if you want to chop 3 digits off, you divide by 1,000. If you want to chop 2 digits off, you divide by 100. If you want to chop 1 digit off, you divide by 10, right? So, um, so divide by 10 to chop 1 digit. Divide by 10, or sorry, 100 to chop 2 digits, etc., right? So we can figure it out. So let's see, int area code equals, now it's going to be the phone number. You just need to count how many digits you need to chop. 1, 2, 3, 4, 5, 6, 7, right? So the normal phone number is 7 digits. And so notice that like the way this is to chop 1 digit, you need 10, which has 1 0. And in order to chop 2 digits off the end, you need 100, which has 2 zeros. So if I need to chop 7 digits on the phone number, then I need to divide by 1 and then 7 zeros. 1, 2, 3, 4, 5, 6, 7, like that. Okay, so that should do it. And we could do system dot out dot print line area code. Run it, and we get the 209. You could you get the rest of the phone number? I think you could, right? Um, because this right here is going to give you those 3 digits, but then how about the rest of the phone number could be the PN modulo 1, 2, 3, 4, 5, 6, 7. You'd have to divide by 7 zeros. So we have the area code, and then we should be able to print out the phone number with the modulo, and we should get the 3846000 down there. See? So you can be creative with these modulo and division operators and actually do a lot of stuff like getting a particular digit, chopping off a certain amount of a number, etc. And so the reason we didn't do this before is that took quite a while here. Now, just looking back at the lecture slides, um, let's just see if this makes sense here. So you could use modulo to get the last digit of a number. Okay, so number modulo 10 on 7549 will give you a 9. Cool. You can get arbitrary digits from the number by dividing by a power of 10 and then using modulo. So this is just what we talked about here. So even if you don't look at it right, like the way you should look at this number divided by 100 modulo 10, you should understand that number divided by 100, that's chopping off 2 digits, right? 2 zeros chops off 2 digits. So you just have 75 left. And then modulo 10 will give you the last digit, but the last digit of the 75, which is 5. So when you do number divided by 100 modulo 100, you get the hundreds digit, which is a 5. Cool. Here's an example of getting all of the numbers from a particular digit, right? So if you want the last digit, the 8, you just do mod 10. If you want the second digit, divide by 10, mod 10. If you want the third digit, divide by 100, mod 10. If you want the fourth digit, divide by 1,000, mod 10. If you want the fifth digit, divide by 10,000, mod 10, right? So it would print 84317, 84317. Cool. All right, so that's just what we did. So you can look in the notes for an example of that if you are curious. These could have been put in any order, like doing the last one does not depend on any of the ones that come before it, and so on. Um, I was just building up to calculating the last digit or the first digit. All right, so that's going to be it for this lecture, and I will talk to you guys later.